Welcome all. Now I am going to discuss question number 34 from the GATE 2021 paper Electrical Engineering. The question is, in the figure shown, the self-impedances of the two transmission lines are 1.5J per unit each and Zm equal to 0.5J per unit is the mutual impedance. Bus voltages are shown in the figure in per unit. Given that delta greater than 0, the maximum steady state real power that can be transferred in per unit from bus 1 to bus 2 is. These are the given options. To know the detailed modeling of synchronous generator, audience can go through the given NPTEL video link. Let us discuss few important things needed to solve the problem. Here, two inductors L1 and L2 are connected in series and the type of mutual coupling is additive. So, the effective inductance L equivalent is equal to L1 plus L2 plus 2M. Here, two inductances are connected in series and the type of mutual coupling is opposing in nature. So, the L equivalent is equal to L1 plus L2 minus 2M. Similarly, if we observe here two inductance L1 and L2 are connected in parallel and the type of coupling is additive in nature. So, the L equivalent is equal to L1 L2 minus M square by L1 plus L2 minus 2M. And in the second figure, L1 and L2 are connected in parallel and the coupling is opposing in nature. So, the effective inductance is equal to L1 L2 minus M square by L1 plus L2 plus 2M. If we observe the difference between the two formulas, here mutual coupling is opposing in nature, right? So, the value of L inductance should be low as compared to the additive coupling. Since the denominator of the L equivalent is more, so the effective inductance will be less in the subtractive coupling as compared to the additive coupling. Let us solve the problem. It is given that self-impedance Zs is equal to 1.5J per unit of each transmission line and Zm is equal to 0.5J per unit. And also it is given that from the figure we can say that the type of coupling is additive. Right? So, L equivalent as we have discussed earlier, that is L1 L2 minus M square divided by L1 plus L2 minus 2M. But these are the inductance value, right? We need to convert this expression to impedances. So that is L equivalent is equal to multiply and divided with omega square. So L1 L2 minus M square divided by L1 plus L2 minus 2M. If we further simplify this expression, L equivalent is equal to omega L1 into omega L2 minus omega M square divided by 1 omega, we will take it out. So, omega L1 plus omega L2 minus 2 omega M. Multiply this omega to the L equivalent. So, omega into L equivalent is equal to omega L1 into omega L2 minus omega m square divided by omega L1 plus omega L2 minus 2 omega m. So we know that omega L is equal to XL, right? So Z equivalent is equal to ZS into ZS minus Zm square divided by ZS plus ZS 1. This is ZS1, ZS2. ZS1 plus ZS2 minus 2Zm. So if we substitute the values of ZS1 and ZS2 in the question, it is given that ZS1 as 1.5 and ZS2 is also 1.5 and Zm is 0.5. So 1.5 into 1.5 minus 0 square divided by 1.5 plus 1.5 minus 2 into 0.5. So 2.25 minus 0.25 divided by 3 minus 1. So that is equal to 1. Z equivalent is 1. In the question, it is asked to find the maximum steady state power. We need to find maximum steady state power. Maximum steady state power, that is equal to EV by Z equivalent. So that is E is E only. Sending end voltage, receiving end voltage is V and the Z equivalent is 1. So that is equal to mod E into mod V. So the steady state maximum power is equal to, so option A is the correct answer. Thank you.